It's a pleasure meeting you once again. Thank you for watching and subscribing and liking this channel. This is a platform where we make social studies easy and you be able to enjoy your lessons and make a lot of notes aside what you have been having in class. It's a new academic year and we are in the second term. We have been talking about a lot and discussing a lot of topics. We've had a lot so far. This time around, we are moving into a new direction, taking one topic under the environment. And we already studied that environment and environmental problems evolve a lot. And here we are again looking at another topic that I hope you enjoy, and I believe that you make a lot of notes out of it. In your schools, as students, you be taught this topic, and at the basic school level or junior high school level, if you are schooling in Ghana. Now, we have to look at this so that it will serve as a revision class or a revision note for you so that you can always refer. But that does not mean that you should not concentrate on what is being taught at school. So follow me closely and we are going to delve into this topic and you will enjoy it. My topic is mapping our environment. Mapping our environment. So we defined environment as the physical and social surroundings. And we know that when we talk about the physical and social surroundings, we are just referring to our immediate surroundings. What happens around us and the features we see around us, the trees and the water bodies. So how are we able to use these things to show direction? I'm sure that has not occurred to most of you. I know most of you out there to use a lot of these physical features to show people locations in your area and direction in your area. So that is all that mapping our environment is about. So when we say mapping our environment, it's actually an activity. It's a process. It will never stop. Wherever you are located, there is something there that you can use to show people the direction or the exact location where you are. These days, we have a lot of smartphones. New ones are being created, and there are maps on those smartphones. You can download the apps, and they actually direct you, show you a lot of locations. So it is not actually easy to know a place at all. But we as students, as geography students and social studies students, should know how those things are so important and how they are being designed to help us understand how places are being located on these maps. So we are going to look at those items and see what they actually do for us. Well, in the past or in the olden days, we can say that we didn't have instruments like the compass. We didn't have people going to school to study how to calculate bearings or angles, talk about latitude and longitude. These terms are so huge and they will sound strange to you. Yes, indeed. The people in the olden days, the world or the part where we come from, have been depending on one natural thing, and that is the position of the sun. The position of the sun. So you hear people use the position of the sun and the rising of the sun and the setting of the sun to even tell the time, to tell the exact time. We have had great hunters who go to the forest, and because of the thickness and the deepness of the forest, some of them may miss their trails or their path. So they depend on the position of the sun to locate their direction or their way home. Okay, so how is this done? The position of the sun is the first factor we are going to consider when showing or determining the direction of a place. So we have the sun. Good. So the one who is depending on the sun to determine his or her direction or location will have to consider one thing or know one thing first. that the sun rises from the east and sets in the west. So the sun rises from the east and sets in the west. Okay, if the person knows this, the only thing he or she has to do is to use his arms, stretch the right arm towards where the sun rises from. So from where I am standing, this is where the sun rises from. So if I'm able to stretch my arm, or if this is where the sun rises from, I'll stretch my right arm to point to the east and then my left arm to the west. If I'm able to do this, then automatically I will face the north and my back will point to the south. So with this simple demonstration, you can tell whether to go northwards, eastwards, westwards, or southwards. So this is a simple demonstration for someone who is depending on the position of the sun to tell his or her location or direction. Okay, so that is it for the position of the sun. Now, someone who can depend on the use of the compass. The use of the compass. So we are now looking at the second factor. How will someone depend or use the compass to identify a place? So the compass is an instrument used in showing direction. It's very helpful. It's very helpful. Those who know how to use it can actually use it to show their location or direction. We can talk about great sailors or people who travel by sea, the navigators. They use a lot of compass because on the sea there is a broad path. You can't actually see land, you can't see buildings on the sea, you can't see all these structures that you see on the land. That will even help someone who is traveling on the land to be able to identify places or locate wherever he or she is going. But on the sea, anything can happen. When someone gets lost on the sea and the person wants to use the compass, the person has to consider this, the four main cardinal points. So cardinal could mean principal. So the main points, the cardinal points or the principal points of the compass, we have the north, which I always regard as the mother. So when you're able to locate the north, you can get the rest. The direct opposite of the north is the south. Then we have the east and the west. So these are the four. So it is read as north, south, east, and west. Don't mess it up. North, south, east, and west. You can draw this. It's very simple. You just draw a vertical line indicating the north and south. This is a pole, so we call it the north and south pole. So this is the north pole, and this is the what? The south pole. Then we have the east and the west, which is the horizontal line. I hope you can do this. So get your pencil and your pen, and you can do this along as we create the compass and see how it looks like. So what also makes it easy is that there are times that the location can fall here. So if the location falls here, then how are we going to identify it? That means that there are places or positions here that are also points on the compass that have been named. So what do? When you have this, and these four spaces, you divide you draw a simple line to divide the north and the east, and let that same line divide the south and the west. and because it falls in between the north and the east, and the north is seen as more cardinal than the east, you bring the north first and then you add the east, and we call it northeast. You come to the other side where you have this and this. We see, consider this as more cardinal than this, so we call it southwest. I hope you got that and you have been able to draw this. You create the other diagonal line, the other side, dividing north and west. Make sure it passes through where we call the origin. For the sake of this topic, we call it a fixed point. It's a fixed point, never change. That's the middle, the center. And we name this south and the east. South is considered more cardinal than the east, so southeast. Then the north is also considered more cardinal than the west, so this becomes northwest. Okay, now we have 8, so this becomes the 8th subdivision of the compass. If you count the points, you have 1, 2, 3, 4, 5, 6, 7, and 8. These are the 8 points. Now that we have this, we can further break them again into 16. What do? So I always tell students the easy way, because it looks very confusing. You are not careful, you draw a line and it is going to cross or enter another space. So you have to cross here, this part, and then this. So you can use your pencil, put an alphabet here, A, and put it also on the opposite side. So it's just like vertically opposite. Okay. Then you put B here, another B here. Put C, the next one, and put the C here. And then let the D be in the last one, and D be here. Okay, so when you have this, you now pick your pencil and draw a line to divide where the A is located, the space in which the A or the A's are located. So you have that. Okay, then you come to the space for the B. You can erase the B's, take your rule and your pencil, and then draw that. Then you take your C's out, draw a line, pass through the origin, and then you name it. Finally, you take your D's out, you have the space, and then you draw the line to divide it. Count and see if you are going to get the 16 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have this. Good. So how do we name them? North is considered more cardinal than this. So you bring the name north and then you add northeast. So it becomes northeast. You go ahead. Then east now, remember it was here before this one came. So we consider it as more cardinal. So you have your east, northeast. This east, the main east, and then this northeast will be the name for this position. Then you move to this one, your main east again, then southeast. Your main south, southeast. Here, in between, your main south, southwest. You come to this one. Main west is here, more cardinal than this. Becoming west southwest. Main west again, northwest, west, northwest. Then you have the final one, main north, in between the main north and northwest. So main north. Then you have the northwest. So you have the 16th subdivision of the compass. So when you pick up a prismatic compass, so the word is prismatic, you have to get all these positions on it, or these points. Good. They all have bearing, they have angle, because the compass has a needle, and the needle can be similar to what you see on a clock. So that one, the second one, handle, that goes round in anti-clockwise direction. So if someone starts a journey from the north, it begins from 0 degrees. If the person gets to the east, remember, in mathematics, if you have this, you have a right angle triangle, and the angle there is 90 degrees. So if someone travels from the north and the person gets to the east, the person covers an angle of 90 degrees. So the east will become 90 degrees. And the west becomes another plus 90, making 180. 180 degrees. Plus 90 again, 270 degrees. And then back to the north, you cover an angle of 360 degrees. That angle can also be referred to as bearing, which has also been indicated here as one of the factors to consider when showing a direction or determining the direction of a place. So we'll look at how to use bearing, and it involves a bit of calculation. We'll get into that soon. But with the compass for now, the needle is what is going to direct you. So the compass is made in such a way that there is a magnet embedded in it. So the magnet is inside the compass, and this magnet communicates or relates with the magnet of the earth. Okay, so this may sound a bit confusing, but relax. With the earth, we have the structure of the earth is in such a way that the most interior part of the earth is called the inner core. And the next one is the outer core. In the inner core, it is solid. The outer core, there is molten magma here. So we hear about volcanic eruption when there is an eruption where the liquid substance that is very hot and burns like fire is here. As the earth rotates around the earth, it generates a lot of energy and force. And this force causes a lot of heat inside the outer core. And the outer core generates what? Current. And this current produces the magnetic field. So the Earth's magnetic field is in the outer core. So what happens is that because the magnetic field is here and we are on this side is called the crust. Before the crust, we get to the mantle. Okay, so on the crust, you have your compass, which one of my students designed. You can also do same out there. It doesn't have a magnet inside, but it shows the point, the leavings, and the bearings. The angles are there. So you realize that with this is the middle, the origin, and then the needle rotates in that manner. Okay, so if you have the compass, which you can find on traveling bags, people buy them and they look like watches, but travelers, they use them a lot. So it will be the magnetic field here will be controlling the magnet of the needle of the compass because it contains the magnet, and that will tell you where you are going. Okay, so because if you place the cardinal point on this, you have the needle rotating. So wherever you are going to, the compass the compass needle will move or point to that direction, and then you move towards that place, if that is where you are actually heading to. Okay, so we have stated that because of this, there is a movement that has to take place. So anyone who wants to use a compass to show or determine his or her location or direction must first of all know how to move steadily with it. So as you move, the needle will. When no movement has taken place, the compass needle will be at rest. To be at rest. And take note, when the compass needle is at rest, it points to the north or the North Pole. When the compass needle is at rest, it points to the North Pole. Okay, so we have mentioned the compass as one of the instruments used in showing direction. All right. Now let's look at landmarks. So landmarks are actually physical features that we find wherever you are located on this earth. There are landmarks there. The physical features that are or can be easily identified in our locality or wherever we live. So you may have a church building. You may have a church building in your area, a school building, a road, a bridge. All these are the landmarks. On the map, if someone is using a map, the person is going to look for the signs. There are signs and symbols that are used to represent these features, but they don't draw the building on the map. They are too huge. They can't draw them. The map is just a paper. Okay, so those who study the map, that we call cartographers. So the cartographers are actually having a cartograph, like a paper, so they spread it and they have the symbols on them. So the scientific study and design of map is known as cartography. So it will end with Y, not ERS. If you are talking about the study and the word used to describe the scientific study and design of maps, that's cartography. And then the people who do that are the cartographers. Okay, so we look at some of the key symbols, the landmarks that you see, and you are able to tell that this one is representing a church, a first-class road, third-class road, a bridge, a castle, a fort, and so on and so forth. We pick few ones, and you will be able to look or search for more. Okay, now with school. So pick a landmark. If it is a school, you'll see this on the map. So anywhere you find a symbol, a sign like this on the map, or an inscription like this, it means there's a school in that location. If it is a church, there is this crucifix, or what people usually call a cross, or there's a CH. Where there is a farm, you have this shaded box with FM. So these are the symbols or the sign. Let's see bridge. You have this, or you can have it the other way. So that's for the bridge. It's a railway. You have one portion shaded, you skip the other, you shade this one, and then that is how, depending on the length of your rectangle that you draw. That is for a railway. There's a fault. There's a fault in the area. In Gold Coast, we had a lot of faults. In Ghana, we are still existing some of the castles. You have something like this. For a castle, you have this circle with a diagonal line crossing it. For a dam, you have this as a river, and then you have this diagonal line crossing it. So if it is a waterfall, you have two diagonal lines crossing it. If it's a dam, just one. Normal river, if it's just a river, you see this. And they use blue colors to show that there is a water body or a river in that location on the map. Blue color blue. If it is a highland, you see a shaded triangle, or they normally write a peak, the highest point of the island, the mountain. Okay, so these are common ones. There are a lot of them, and we can keep on writing and indicating their conventional sign on and on. So we have seen landmarks and their conventional sign. So landmarks are also very important when we are trying to indicate the location of a place, or the direction of a place. They are very helpful, and I'm sure there are some of them you've already identified in your area that you can actually use to direct someone to wherever you are living. I think you realize they are helpful now. So always be conscious of what you find around you in your environment. It could be a big tree, it could be a very huge facility, a hotel, or an organization. Okay. All right. So another factor to consider is asking for help. While it is in the forest, people are advised that you shout for help. If there's a hunter passing by, the hunter can actually, or if someone is using that road or a road close to the forest, the person can help you out and take you to wherever you are going. But when in town, you can still ask for help. I always advise students to make this their last, or you can't trust people nowadays. So asking for help is not 100% recommendable. Okay. The use of maps. So we'll be looking at maps now, and we see the kinds of maps, and then we see why we have maps and we have a sketch. Okay, so that is it for the factors to consider when determining the direction of a place. We'll look at the angular bearings, where we take some few calculations, and then you see how we can also use the bearings to also show location of a place. I hope you've enjoyed the lesson to this point and you have taken note of certain points so far. Good. All right. So we'll look at the difference between a map and a sketch. When you take a map and a sketch, you see that there is a map is a visual representation. So visual representation has a visual representation, but the sketch has a rough representation. So another one is that it's the Earth's surface or part of it. this could be anything. A sketch could be anything. You can have a sketch of your house, I have a sketch of someone, but here we are focusing on what we draw to show location. So we say a sketch of a map or something. But like what I've done here, this is a rough representation. So this is a sketch. It is not drawn to scale. It is not drawn to scale. But this is actually drawn to scale. Maps are drawn to scale. So when you pick an atlas is a book containing maps, so a collection of maps. When you pick an atlas, you find these maps in them, and they have written some numbers under these maps. And then sometimes they draw something like this. Then you have a number here, and then you have another one. You say it's in kilometers or in meters. Then you see 0, maybe 1,000, 2,000, 3,000 in that order. It could be 50, or it could be 10, 20, 30, 50. So you have this as a scale. So always when you pick the atlas, look at the drawings and then the maps, and then go to the bottom. You find a scale over there. They are normally placed here. Okay. So what are the features that you see for you to know that a map is a good map that has been drawn in an atlas, or what you are seeing is a good map? Okay, first of all, so we've already talked about what? The scale. So you find something like this under it. So this becomes the scale. So the scale of a map, since I drew this first, let's look at the point 4 first. So the scale shows the representation, or the scale shows the relationship between two things. Now, the distance relationship between So the relationship between the distance measured on the ground, we also call it actual distance or ground distance. That is where you are. When you measure, you know you are going to use a lot of days or hours to even take that measurement. But on a map, because you are using a paper, the space or the length is not that huge, or you will be able to, or the distance is not that long. So you'll be able to use the normal rule to take that distance or measurement. Okay, so when you measure 2 points, if I place town A over here and town B, the distance between town A and town B will be called the map distance, not the ground distance. This is the distance on the map, so we call it the map distance. So the scale is the relationship. So it shows the relationship between the distance you have on a map between the 2 points, and then the distance that you have on the actual ground, or the actual distance, or the ground distance. That's the definition for a scale. So when you know that if you measure maybe from your doorstep or from your house to the lorry park, if it is going to take about 2 kilometers, now when you come to the map and you put a location, that 2 locations, that this is your house and this is the lorry park or the car park, then you are going to say that every 10 or every 1 kilometer, I'm going to use what? 1 centimeter to represent it. Because you need this one on paper. And what the distance you are measuring, you can't have kilometers on paper. So you are now going to look for these numbers to bring the scale or to reduce the distance on the actual ground on paper, because the distance on the actual ground is huge. So you are going to connect it to another number that will make it smaller for you to draw the two or locate the 2 points on paper. So that's what we call the relationship between the distance measured on the ground and the distance measured on the map between the 2 points. So that is a scale. So measured on the ground and the map and the map distance. That's a scale. So the scale is very helpful. It will help us to make sure we have a smaller figure or a smaller map compared to what we have on the actual ground. Okay, so that's what the scale helps us to do. Well, we look at the title of a map. If a map is a good map, one key feature you see is the title. The title, you always find it at the top. So if it is a political map, the political map of Ghana, the political map of Ghana, so you see it, and it will be showing important towns, it will be showing regional capitals, it will be showing the main capital, and then it will show other towns or maybe districts. So the administrative regions and the whole settlement, you see the demarcations and the borders or the boundaries in there. That's the political map. If it is vegetation map of Ghana, you see where we have plant life, forests, trees. You see that where we have grasses, where we have short or tall trees, all these places, you see them on the map. So that is the title of the map. So let me just indicate it. So I'll use the drainage map of Ghana. Drainage map will show water bodies. To show water bodies. Okay. So this becomes the title. This is the title of my map, the drainage map of Ghana. So you find the rivers in Ghana and the lakes. So you see them, Lake Volta, River Volta, you see Oti, you see Afram, you see Pra, all will be indicated. That is the title of the map. So what does the title of the map do? It gives you an information of the map and tells you what the map is representing, what it's about. Okay, so let's move to another one, the key or the legend. A good map must have a key or a legend. Now, there is always a difficulty in interpreting a map. You can know the title all right. You know, okay, this map is showing what? Water bodies. If it is a physical map, it will show highlands and lowlands, mountains, plains, cap, where they are located. Good. But how do you identify whether it is a what? A mountain, whether it is a highland, or whether it is a hill or a scarp? How do you know the height? So they will use symbols. Now these symbols, you find them being located in a certain box. Normally they put it down there and you write key or legend. And you see the names of the things that they have used, the colors, the signs, the symbols that they have used in the map. You find them here and then you see their names. So the key or the legend helps you to interpret the map, because it shows the meaning of symbols and the meaning of colors used in the map. That is what the key or the legend does. Okay, can we move on to the direction now? So the direction of the map, or the direction of a good map, is talking about what? The compass point. We've already talked about the compass point, where we have this. So you always have it. So you can place it around here and or place it around here, then you see the north pole. Or when they indicate the north pole, you can get the 3 other cardinal points. Okay, so you have a compass point. A good map must always have this. So you know that if you are moving towards this direction of Ghana, you are going to, or you are going northwards. If you come to this side, you are going or moving southwards. To this side, you are moving eastward, and to this side, you are moving westwards. So this is also very helpful. The compass point or the direction of a map. That's another feature. Okay, since we've already talked about the scale, we jump to the grid. The grid. What does the grid tell us? On the surface of the globe, I will say the Earth is spherical in nature. When you see this, you see a line drawn from the North Pole to the South Pole. You know what I call the Earth axis or the polar axis. So this vertical line connecting the pole to the, just like we had on the cardinal point. And you have one connecting the east to the west. We call it the equator. From there, you have other lines drawn on the surface because we want to know the exact location of places. All locations are not on this line, and all locations are not only on this line, the east and the west. So we can have other locations too here, but how do we get them? We need to draw these lines, connect them in a way that we will be able to locate places. So we call these ones, the vertical ones, longitude, and we call these ones latitude. The horizontal ones latitude, the vertical ones are longitude. So when you have this on the map, you are able to tell the exact locations because this one horizontal line could intersect or meet with the vertical one, and then you can know the point. So if a town is here, you just read the angles or the bearing, and then you get the location of that town. Okay, so when you look at this, after these lines have been drawn, they are imaginary lines. You can't find them on the surface of the earth. When you go out, you don't see them on the ground. They are imaginary. So they draw them on the map to help us know the exact location of places. So when you see these boxes, they look like the grid. So these boxes are referred to as well the grid. A good map should have these lines on the surface. So when the horizontal lines and the vertical lines meet, they will show or they will display these boxes for us. And they are very helpful for us to identify location of places or map our environment very clearly. So we call this grid. That is a grid of a map. A grid of a map. Then a date, which is not always there. It is optional anyway. If you are drawing a map like a historical map, so maybe a map showing how we had when we had a colonial map, let's say the Gold Coast, where we have the Transvolta to Holland, Gold Coast colony, the year, you see a date, you see a year over there showing the period. You could also have ancient map showing the empires, and you see the years over there, with the BCs and the ADs, how the maps look like. With those ones, it is required that you add the date or you put the date at the top to show that it is a good map. It gives a lot of information to those reading the map, So these are the features or the characteristics of a good map. Okay, hope you got them. Now that we know the difference between the map and the sketch and the characteristics of a good map, we'll quickly move to the bearings, angular bearings, how to use the angular bearings. Alright, so before we look at the angular bearings, let's look at the type of scales. So we have said that the scale shows the relationship between the distance measured on the map and then the distance between 2 points measured on the actual ground. So there are 3 types of scale. So we have the statement scale, the linear scale, or the representative fraction or ratio. These are words. The word that comes into mind when you see statement, word. So statement scale is a scale in a statement form or in a word form. So you have something like 1, you see 1 centimeter to 10 kilometers. 1 centimeter to 10 kilometers. So you see the word 2, and you know that it is in a word form. That is how it is read. 1 centimeter to. So the same scale here. Let's see how it will look like if it is under linear. With the linear, you find a straight line. Here you draw. So the scale in a straight line form, just like what I did or indicated under the Ghana map. That was an example of a linear scale. So you have this, that. You can put the main one here. So the main division, we call them primaries. We call them primaries. In between, 1, 2, 3, 4, can put some. We call these ones secondaries. So the minor divisions or the subdivisions are called secondaries. The main divisions are called primaries. These ones. Okay. So now let's put this figure on it. We just write a unit here, kilometers. At times people also write it here. It's accepted. If you have not indicated any secondaries in between these two primaries, you can put it here. But mostly, just try and put it here to avoid any clumsiness of the drawing. Put your 0 here. The next one is what is 10 kilometers. So what this means is that every 1 centimeter on the map, which is the map distance, will be equivalent to 10 kilometers, which is on the ground. That's why we say the scale is what? The relationship between the map distance, this is the map distance, it's always in centimeters. Because you can get centimeters on your rule, and then use it to draw a line on a paper. So that is why it is easy. So you are reducing this to this, and you are connecting. So there is a relationship. That's the relationship between the distance or the distance between 2 points on the map and the distance between 2 points on the ground. So this is the ground distance. Always you find it in this huge unit, meters or kilometers. Okay, so you place the 10, then it will have an interval 20, 30, 40, 50, and so on and so forth, depending on the number of primaries that you have indicated. Okay, so if it is 1 centimeter to 5 kilometers, you have 0, 5, 10, 15, so multiples of 5 in that order. At times, they put the 10 here, and then the next one will be 0 in that order. When you see the number here first, this one here, it tells you that that's the interval. For example, if I have 7 here, and I have these primaries, then I have to begin from 0, so the 7 will be my interval. 7 kilometers, 14 kilometers, 21 kilometers, 28 kilometers, and I put the unit here. So it continues. Okay. So this is a linear type of scale. Linear scale. Let's see how it becomes representative fraction. The same. So when it gets to this point, it means that there must be a conversion. In representative fraction, you have it in a what? In a fraction form. So but we don't write the kilometers. Something has to happen to this one, and that is where we deal with the conversion of scale. For it to be, the number will now increase, because the rule for the representative fraction is that the unit of the numerator should be the same as the unit of the denominator. Okay, so how do you get that? Let me just draw a line. How do you get that? Now, you remember two major formulas. Let me give them to you. So you have to take note that every 1 kilometer is equivalent to what? 100,000 centimeters. Then 1 meter will be equivalent to what? 100 centimeters. If you know these two, you can always convert the scale. So when the figure is given, when the actual distance or the ground distance is in meters, you use this one. Okay. When the actual distance is in kilometers, you use this. Just like this. So right now we have this one in kilometers. So we have to convert it into this and get the ground distance for our denominator. Okay, so if you have 10 kilometers, how many centimeters can make the 10 kilometers? And it is simple as that. What you do is that you just multiply this by this. So if I have 1 centimeter, which is equivalent to 10 kilometers. 1 is equivalent to 10 kilometers. And I want to convert and change this, which is in kilometers, to what? Centimeters. Then I'll just bring the formula in. So which one will come? You put the ones in centimeters on one side. Which one is in centimeters? This one. So 100,000, you just put it on one side. This for simple beginners who want to understand this calculation. You put the 100,000 centimeters on this side, and then the kilometers is the 1 kilometer. You bring it on this side. Again, you just write the scale given, and then you choose the formula. Because the scale given, the actual distance is in kilometers, you choose the formula that has what? The kilometers. And we said you group the centimeters on one side and group the kilometers on one side. So you have this. Then you cross multiply. When you cross multiply, you will now get what? 1 is equal to 1. Then this 0. When you multiply, you see that the 0 now become, this is 1, 2, 3, 1, 2, 3, 4, 5. So you now have 1, 2, 3, 4, 5, 6. So you have 1 million. Okay, so this becomes your what? Your ground distance in centimeters. Therefore, if we have that, the ratio fraction or the representative fraction or ratio scale for this particular scale, what we have there will be 1 over, the fraction form will be 1 over 1 million. Or then you write the ratio form 1:1 million. You don't bring the unit again because it is understood that in representative fraction scale, the unit of the numerator and the denominator are the same. So you maintain it like this. So this is what you get. Okay. So you have done ratio and proportion where you are taught that if less, more divide, if more, less divide. You just apply it here and convert your scale. There's a mathematics lesson where you'll be taught how to convert scale. But this is what you can get for this one, so that you build on it. Alright, so now that we've seen the types of scale, let's quickly go to angular mapping. So, bearings. So bearing. So we will define it as the angular displacement of a point. That point could be a location. In relation to a fixed point. You remember I mentioned fixed point? Fixed point, I said, if you have this is your fixed point. It never changes. So, you were at a fixed point here and something happened. You change your location. Changing your location is the displacement. You have moved from one place where you are, the origin, to another place. So you have been displaced. So you change your location. And you are definitely going to travel at a distance. Okay, so a distance could be between the north and the east. So north, south, east, and west. The distance, the journey could happen within this area, which we call, so it is 4, so they are all quadrants. We call them quadrants. So this is the first quadrant, second quadrant, third quadrant, and then the fourth quadrant, because the needle of the compass rotates or moves in a clockwise direction. So we have first, second, third, fourth. So when it is in the first quadrant, it means that every angle here, you know, this is 0 degrees and this is 90 degrees. So every angle we are going to get here should be less than 90 degrees if the journey occurred here. If the journey occurred in the second quadrant, every angle we are going to get should be less than 180 degrees. If the journey occurred in the third quadrant, every angle we are going to get here should be less than 270 degrees. And if it occurs in the fourth quadrant, every angle we are going to get should be less than 360 degrees. Okay, so now I have indicated this line. The moment you have this, we can put 2 terms. So remember that when you arrive here, remember a cardinal point can also be placed here, and this can become an origin. But this is where you left. This is where you travel from. So where you travel from becomes your fixed point. So I'm putting A here, town A. So if this is the town A, and you now go to another town that I will call town B, it means that town A is your origin. And this is where you left, and the fixed point. Okay, so there's a relationship between town A and what? Town B. So okay, so Kofi traveled from town A. So A from B, B from A. They are not the same. Okay, this is what it means. If the fixed point is A, and then you got here to your new location, you have been displaced, it means that we want to know the angle of this. One will be given, and then the angle of this. Because the needle had to get to the location from the north clockwise. From the north clockwise. Okay, so you have this and then you have this. Now, if I put 90, sorry, the angle has to be less than that. If I put 60 degrees over there, then it means that we have to know which of these will have the 60 degrees. Now let's watch it. B from A. You are in B now, but you came from A. So it's this one. B from A. That is it. 60 degrees. So town B from town A is 60 degrees. But if I put the angle here, and you are now here, it means that it will be what? A from B. A from B. So if you are given one and you are asked to find, so we now have B from A, which is 60 degrees. Now they said if the bearing of B from A is 60 degrees, what will be the bearing of A from B? If the bearing of B from A, now how do you get a fixed point? The moment you see the from, the alphabet that comes after the from should be your fixed point. The alphabet, always look for the alphabet after the from, then you get your fixed point. So if the alphabet after the from here is A, then it means that A is our fixed point or the origin. So the angular displacement of a location in relation to a fixed point. Relation. So the line is connecting them. So there's a relation. You don't just stay at a place and then before you know, you find yourself in another place. No, you have to travel and cover a certain distance. Now, after covering the distance, there is an angle of which you have traveled, and that angle is what we call bearing. That's what we are calculating. And bearing is always in degrees. In degrees. Okay. So measure it in degrees. So now let's see what happens. It's a simple formula. If you have the angle given in the question less than 180, then what do? You add 180 to it to get your answer. So if town B from A is 60 degrees, you just make it 60 degrees plus 180 degrees, and you are going to get 240 degrees. How do you ensure that your answer is correct or verify that your answer is correct? Look at the 240 degrees. Go and look for the location. Is it in the first quadrant, second quadrant, or third quadrant? We said that if the angle is less than 270 degrees, then it means that it will fall in the third quadrant. So 240 should fall in the third quadrant because it is less than what? 270 degrees. Now look at B. A from B. A from B. A from B. You got to B, but you are now back to A from B. A from B. A from B. Now check the line. A from B, this is the angle. You cover this whole angle, 240. It is in the third quadrant. The line is in the third quadrant. The line is in the third quadrant. So our answer is correct. Our answer is correct. I'll give you one more example and then you will get it from there. Now, let me take this location from here and I'll put it here. So A again, town A again, and then the person got to town B. Okay, so the angle has been given that when the person traveled to town, so now let me use X and then town Y. When the person traveled to town Y, he covered an angle of this is less than 180, so we give an angle less than, so 160 degrees. This bearing, cover the bearing of 160 degrees. So we are now going to look for this, the whole of this angle. So now the person is back to down X, and then we want to know the bearing or the angle that the person covered when he traveled back to down X. So now the formula, so let's interpret this. X from Y, Y from X. Which one has the angle? Which one's angle has been given? I said, how do you know? Look for the alphabet that comes after the word from and make it the fixed point. From what we have here, the alphabet X is what? Is the fixed point. So, and it is after here, it's after the word from. So this will be the word 160 degrees. Now 160 degrees, is it less or greater than 180? We always use 180, it's a constant bearing or figure we use. So it is less than 180 degrees. So what do? If it is less than 180 degrees, you add 180 degrees. But if it is more than 180 degrees, you subtract 180 degrees. So now that 160 degrees is less than 180 degrees, what do? You say 160 degrees plus 180 degrees. What are we going to get? We'll get 340 degrees. Let's check whether our answer is correct or not by finding which quadrant that 340 degrees can be located. So let's go to the diagram now, the two diagrams. Now it is now X from Y that we are looking for, but this is what we've been given. So if it is X from Y, then Y becomes the fixed point now. And in this place, it is Y that is the fixed point. Because the person journeyed back to town S. So this whole angle. Now where is the line located? The line falls not in the first quadrant, not in the second quadrant, not in the third quadrant, but in the fourth quadrant. So, and 340 is less than 360. So our answer is correct. Our answer is correct. This is how we calculate bearings and we get our location. But so when you travel wherever you are, you get to a place and you know this calculation, you know the angle at which you travel or covered or the bearing from your fixed point where you left to your destination. You can use that angle and calculate the bearing when you travel back to where you left or the fixed point, and then you get both angles, so you'll be able to show the direction or the location. That is a very simple thing. There are more examples in your textbooks that you've been given. Continue solving them, get more examples, get the video, download it, watch, subscribe, like, share to others, and have group lesson, and you'll be able to understand better and better. And I believe today we've enjoyed ourselves here. We've had a lot. We've talked about the meaning of map in the sketch. We look at meaning of landmarks in the examples. We've seen the compass and how the compass is developed, and we've also been able to look at how to calculate bearing. What about the scales? The scales, the three types of scale, the linear statement and representative fractional ratio. And we've been able to see how to even convert the statement scale into representative fraction scale. Continue practicing as good students out there. This is all I have for you today, and we will be having more lessons again, but for now we will call it a wrap on this platform. Keep watching Giselle Tutorials, and keep subscribing and liking my videos.